So in today's class, we are going to discuss the solution concept for LPP. The solution concept of LPP. We will discuss here various methods, but firstly, we are going to discuss the graphical method. As its name indicate, graphical methods. So when we want to use the graphical method, the one thing is here the number of variables which we are dealing, that should be 2. And because we restrict to the first quadrant, then we say that the variables should be greater than equal to 0. That means the minimum value of the variable should be 0, right? Before starting this, you should understand two types of solution concept. One is your feasible solution, and one is your optimal solution. So what do you understand from feasible solution? You can say a set of variables that satisfy constraints as well as my no-negative restriction plus my no-negative restrictions. So वो वाला solution, वो वाला variables का set जो मेरे सारे constraints को satisfy करेगा और no-negative restrictions भी means वो आपका greater than equal to 0 भी होगा, that you call as your feasible solution. Optimal solution means वो वाला feasible solution that will give maximum or minimum value as per for considered LPP. If it is maximization case, then it should give me maximum answer. And if it is minimization case, it should give me minimum answer. So that solution, I will say optimal solution. So we will start with the example. So let my first example is the objective can be maximize or I can take minimize, anything we will do for both the cases. I have 3x1 minus 2x2 subject to that is less than x1 minus 4x2 less than equal to 15, x1 plus 8x2 less than equal to 15, x1 is greater than equal to 2 and x2 is greater than equal to minus 8. So the benefit of graphical method is that there is no need to convert LPP into its standard form. So we need not to convert that the problem into standard form. We can directly solve it. The negative point of this is that it is only restricted for 2 variables. Only for 2 variables. That means graphical method, which I am saying, that will be restricted only for 2 variables. If I have more than 2 variables, I cannot apply graphical method, right? So because we have to remain in the first quadrant, so हम क्या कह रहे हैं, हमारी पहली condition यहाँ पे satisfy है that I have number of variables are 2, that is my x1 and x2. But the second condition, it says that x1 and x2 should be greater than equal to 0. That is not satisfied over here. So that we can make, that we have already earlier done, that I can write it as x1 minus 2 greater than equal to 0, and I can give name as new variable y1 greater than equal to 0, and this will be x2 plus 8 greater than equal to 0, and I can give name y2 as, so here from x1 that will be my y1 plus 2, right? And my x2 that will be your y2 minus 8. So wherever you're in LPP, x1 is present, you will replace with this term, and your x2 is present, you will replace with this term. So your given LPP will transform into maximize z 3 y1 plus 2 minus 2 y2 minus 8 subject to, you will have constraint, this is y1 plus 2 minus 4 times y2 minus 8, that is less than equal to, this is actually 5, less than equal to 5, and I have x1 plus 8x2 that is less than equal to 15. Now the variables has changed, that y1 is greater than equal to 0 and y2 is also greater than 0. So when you will simplify, it will transform into problem maximize or minimization. Z is equal to, that will be your problem. And you will multiply 3y1 minus 2y2. And here it will be constants, 3 into 2 minus into minus 8. So that will be plus. So it will give you answer as 3y1 minus 2y2 plus 22, right? So now the subject to the constraint, when you will solve it, it will give you y1 minus 4y2 less than equal to minus 29 and y1 plus 8y2 less than equal to 77 and y1 and y2 are greater than equal to 0. Now, since we are two-dimensional, that means we are considering only two variables. So आपको पता है linear combination क्या represent करता है? This is representing nothing but a line. So when we want to graph, when we want to plot it, so I'm naming this as constraint as 1. The name is second constraint. So one constraint, because it is indicating a line. So अगर हमें प्लॉट करना है, हमें मिनिमम लाइन प्लॉट करने के लिए कितने पॉइंट्स चाहिए होते हैं? दैट वी पॉइंट मिनिमम नंबर ऑफ पॉइंट्स टू प्लॉट लाइन, that is 2. So the best way you can take it as equality, just to plot or find the points. Minus 21, 9. So when you will take y1 as 0, so that will be your y2 will be 29 by 4. So you got the point as 0, 29 by 4. And when you will take y2 equal to 0, you will get y1 as your minus 29. So this is your point minus 29, 0. So I have 2 points. I can join them by a line and it will show me a line. If I will consider the second constraint, my second constraint is y1 plus 8y2 equal to 77. The best way to find the point is y1 equal to 0, then y2 will be my 77 by 8. And if I take y2 equal to 0, then my y1 will be 77. So I got 2 points here, that means 0, 77 by 8 and 77, 0. So then I can join them by a line. Then we can talk about what inequality says. So if I am plotting it on a line, so this I can say this is my x1 and this is my variable x2. So now we have point minus 29, 0. So it will be in the negative direction, minus 29, 0. And 1 point we have obtained 0, 29 by 4. So it will be my here somewhere. So that is 0, 29 by 4. So because we have obtained this from one line, so I can join them by a line. So this line is nothing but my first constraint, right? Next, I have 0, 77 by 8 and 77 by 8, 0. So I have 77, 0. This will be this point. And here it will be 0, 77 by 8, that I can join them by a line. So sometimes if you got both the negative values, you can extend that line so that it comes in the first quadrant, because we have taken x1 and x2 should be greater than equal to 0. Now, the thing is, suppose the line is given to you that 5y1 minus 4y2 less than equal to 0. So if you say y1 as 0, you will always get y2 as 0. And if you take y2 as 0, you will get y1 as 0. That clearly indicates that your line will pass through 0, 0. That means origin. But don't say this is the only point. Remember that this is my line. So that means this is the one point which you got कि आपका origin में से pass करेगा. The other point you can take, I can take y1 as 0, 1. And I can obtain the value of others. So my y2 will be 5. That will be my 5 by 4. So that is the another point, y, 5 by 4. So that means I got 2 points. Then I can join them by a line. Please don't take it कि अगर आपने y1 को 0 put कर दिया, y2 को 0 put कर दिया, that is just 1 point. No, you have to make a line, and line can be made by at least 2 points. So this is surely when you have right hand side equal to 0, that will pass through from the origin, and 1 point you can substitute any given value, any value to y1 or any value to y2, and you can obtain the another point. So don't do like that कि आपने 0 point ही बस plot कर दिया and you are not forming a line. Okay. So next come about why this we have sign less than and here. So what it is indicating? So that means now it is a line. This is the line of the first constraint and this is the line of my second constraint. Now you can see कि इस line को portion में divide हो रहा है. That line can either can go upward or can go downward. So how should we decide कि ये line upward जा रही है या downward जा रही है? So that we can decide the constraint which we have given y1 minus 4y2 less than equal to minus 29. So the best way is that you can check at one point you have origin point here, right? So you can substitute y1 as 0, y2 as 0. So that will be 0 minus 0 less than minus 29. 0 is less than 29. Minus 29, no. So this constraint is not satisfied for 0. That means my this line 1 will go away from origin. ये आपकी origin के पास नहीं आएगी अगर आपका constraint वो satisfy नहीं हो रहा, right? The same I am repeating. You can take y1 and y2 as 0. If your constraint is satisfied, तो आपकी line जो है वो 0 के towards आएगी. Otherwise, it will go away from origin. The second constraint you have y1 plus 8y2 less than equal to 77. Now in this case, if you substitute y1 as 0, this is 0. So your 0 is less than 77, which is true. That means this line will come towards the origin. Now for both the constraint that x1 and x2 should be greater than 0 and the constraints should be satisfied, you can notice only this is the region where both the constraints are satisfied. और हमने क्या कहा था? Feasible solution क्या है? जहां पे मेरे constraint satisfy हो रहे हैं और no negative restriction. So this is indicating nothing, but this is my feasible region. So this is the set of all the points जहां पे आपके region satisfy कर रहे हैं. So we will do one theorem that we will do its proof just for this understanding. You can notice that this is my closed and bounded region. So I have corner points over here. This is my point A, which is 0, 29 by 4. This is my point B, which is nothing but the intersection of 1 and 2 that you can easily obtain. So this is coming as 19 by 3 and 53 by 6. And this point is nothing but this point is my C point 0, 77 by 8. So whenever you have feasible region, which will be your closed and bounded, the optimal solution will always lie on the corner points that we will do the proof. But here my corner points are A as 0, 29 by 4, B as my 19 by 3 and 53 by 6, and C is my 0, 77 by 8. Now the task comes for the objective function. Now my objective function, when we have transformed 3 by 1 minus 2 by 2, that was my plus 22. Now if I substitute the point A over here, A means y1 को मैंने क्या पुट करना है 0, y2 को क्या पुट करना है 29 by 4. So if you will obtain the point, this is giving me as 7.5, right? And ZB, if I substitute the value, it is giving me as 23.33. And ZC, if I substitute, that means I'll substitute y1 as 0 and y2 as 77 by 8. I'll get the value. This is my 2.75, right? So now the task come, this is the objective function value at the corner points. Now the task is whether the function is maximization or minimization. अगर मेरा function maximization का है, then I will choose the maximum value of Z from all these points. So you can clearly see the maximum value from all these points is 23.33. So which implies y1 V point is the optimal solution, right? V point is the optimal solution. And what is my B point? What is my B point? That is 19/3. And Y2 is my 53/6. So don't end over here, because Y1 and Y2, you have decided the variable, but actually the problem was given to you in X1. So your X1 was nothing, but that was your Y1 plus 2. And X2 is nothing, that will be your Y2 minus 8. So whatever the point you will get, that will be your point 25/3 if you will solve. And X2, that will you will solve, it is coming out to be your 5/6. That means X1 equal to 25/3 and X2 is equal to 5/6 is the optimal solution. And optimal value, what will be your optimal value? When you will substitute in the Z, that is my 3x1 minus 2x2, which you will get by substituting, that will denote your optimal value. This is x1 star and you have to substitute. This will give you the optimal value. So this is the case of maximization and this is the solution. Agar mera yahi wala case minimization problem mein hota, then what I have to find? I have to find nothing but the minimum of ZB, ZA, B and ZC, which is nothing. You can clearly see that this will be your minimum 2.75. That means my C point is the optimal solution. And C point is nothing but Y1 is my 0 and my Y2 as 77/8. So we cannot end over here because X1 was my Y1 plus 2 and X2 that was my Y2 minus 8. So that you will get X1 as your value 2 and you will get X2 as your 13/8. So which indicates that X1 equal to 2 and X2 is equal to 13/8 is the optimal solution in case of your minimization problem. And the minimum value that you can say, that will be your minimum value 3x1 minus 2x2. Okay, this is star, right? So this will be your minimum value. In this way, you have to proceed like this. If we consider the same question, and one thing more over here, like feasibility, we are checking for the 0 point. अगर आपका इस तरीके का ही कोई कंस्ट्रेंट होता जो हमने लिया 5y1 minus 4y2 less than equal to 0, अगर आप इसमें y1 और y2 दोनों ही 0 पुट करोगे, then the constraint will be satisfied at equality. Then you cannot know कि आप कहाँ से कौन सा पॉइंट की बात कर रहे हो. So you can choose any point from the region. I can choose the point 1,0. That means कि मेरा point है 1,0, that will be my somewhat on the x-axis. So line either will go towards x, this point either away. So if I substitute over here, so 5 is my less than equal to 0, which means this constraint is not satisfied. इसका मतलब क्या है कि ये वाली line मेरी इस point के पास नहीं आएगी. It will go away from that point. So if this is the line that it is passing from the origin and you have value 1, 5/4. So this line will not come towards 1, 0. It will go away from this point. So this is not possible. This is possible. So when you have right hand side equal to 0, so you have to consider these points. The same question if we do, and just I am changing the sign of inequality, and then even you can see your region just can change. When you have the same problem, maximize or minimization, the same problem, I am writing it in the form 3y1 minus 2y2 when I have transformed it into this constraint. So I am taking one constraint y1 minus 4y2 that is greater than my minus 29. Earlier it was less, right? And the same second constraint I am taking same, that is 77, that is 77 and y1 and y2 both are greater than equal to 0. Since we have solved this problem, इस लाइन के टूवर्ड्स हमें पॉइंट्स क्या मिले थे, दैट इज 0,29/4 and 1 point I got as -29,0. And for this we got 1 point as 0,77/8 and we got the same point here, that will be your 77,0. So that we have earlier also plotted. The same graph it will be here, but now we have inequality constraint is changed. So this is my -29,0 and here it is 0,29/4 as we have earlier plotted. Like this line is towards the second quadrant, but extended to the first quadrant because we have to restrict only the first quadrant. So this is my point 77,0 and this can be my point 0,77/8. So if I'm join them by a line, right? So this is my second constraint and this is my first constraint. Now we talk about the region. Now you can see from here, now we have first quadrant, first constraint is y1 minus y2 greater than equal to -29. So if I'll take y1 equal to 0, y2 equal to 0, that means 0 is greater than -29, which is true, right? That means now this line will come towards the origin point. Since now you can see clearly from here कि जैसे ही मैंने अपनी inequality sign change कर दिया, the region is getting changed. The same, if I substitute 0, 0 over here, 0 is less than 77, which is true, right? So this line will come towards the origin. Now you can see clearly from here. Earlier this was your feasible region, but now this is your feasible region, which is satisfied by both the constraints, right? So since the feasible region is closed and bounded, so we have corner points A, this I can name as B, this is C is nothing but the intersection of the line which we have already obtained, 19/3 and 53/6, and now we have got this point also as the 0,29/4, right? So these are my points. These are the corner points. I know the value only can lie on the corner points. So my objective function is 3y1 minus 2y2 plus 22. I can substitute the value of ZA. I can substitute the value B. I can substitute the value C and I can substitute the value as D. So this point is nothing but A point is my 0, 0, that is the origin. So if you substitute y1 as 0, y2 as 0, you will get value as 22. And this ZB, you have 0.77, so 3 into 77 minus 2 into 0, that will be give you the maximum value, that is your 253. Right? And that ZC, that is giving you value as 23.33. And at ZD point, you are getting the value as 2.75, right? Now the same question. Now, if my objective function is of maximization, I'll choose the maximum value from ZA, ZB, ZC, and ZD, right? So the maximum value, you know, it is happening over here, 253, which implies my B is the optimal point, right? अगर B मेरा optimal point है, तो मेरा यहाँ से y1 कितना था 77 and y2 was your 0. That means x1 was your 77, that was your y1 plus 2. So that means 77 plus 2, that will be 79, and your y2 was, x2 was y2 minus 8. So this is your point. So my x1 is equal to 79 and my x2 is equal to -8. This is my optimal solution. And what will be the optimal value? You will just put it in the objective function, that will be 3x1 minus 2x2 star. That will give you nothing but the same value which you got over here, maximum over here. Now the same question, if you have minimization case, what you do? you will find the minimum from ZA, ZB, ZC, ZD. Again, you can notice that this is my minimum value at D point. This is your 2.75, which is occurring at D point. So D is the optimal point, and D is nothing but my y1 is 0 and my y2 is 29/4. And the same x1, that is your y1 plus 2. So you got point as this, and x2 is nothing but y2 minus 8. So this is my 0 plus 2, that will be 2. And here your x2, that will give you answer as minus 0.75. So x1 equal to 2, x2 equal to minus 0.75. This is the optimal solution in case of minimization, right? So the minimum value here, that will be your 2.75. That is your optimal value. So just if you change the inequality, you can see your region can change, the solution can change. Even if you change the objective function, maximization, minimization, then also your optimal solution get changed. So the same example we will consider, right? And this we have done the cases जहां पे हमारा फिजिबल रीजन जो आ रहा था वो बाउंडेड आ रहा था, क्लोज आ रहा था, so that I can have corner points. But if I have the same problem, right, I am writing it in the form that we have converted, that is 3y1 minus 2y2 plus 22, subject to if I have constraint y1 minus 4y2 greater than equal to minus 29, and y1 plus 8y2 greater than equal to 77, and y1 and y2 are greater than equal to 0. So the same graph will remain same. That means the plotting of the point will remain same. So the plotting of the point will remain same. So this is my point which I'll get from the first constraint. This is my minus 29, 0, and this is 0, 29/4. These are the points which I got from the first constraint. So this line will be my first line, first constraint line, and from here we got 77, 0 and 0, 77/8. And obviously here you are taking your x2 and here you are taking x1. I can join them via line, and that is nothing but my second constraint. So now the region comes. So now you can see from here that when I substitute y1 and y2 as 0, so this point is my 0, right, which is greater than minus 29, which is true, right? So that means this line is coming towards origin, right? And again, if you substitute origin, this is 0 greater than 77, which is not true, that is false. That means now this line will go away from origin. So now you can clearly see earlier when we have, firstly we got this region, when we have inequality here, this was less, and now we have changed the inequality. Now what is my common region which is satisfying for both the constraints? This is my feasible region. Now you can clearly see here that this can be extended so much, right, that it cannot be bounded. नाउ प्रॉब्लम कम्स, अगर बाउंडेड नहीं है, हमें कॉर्नर पॉइंट्स नहीं मिल सकते. अब हम कह रहे थे सोल्यूशन कॉर्नर पॉइंट्स पे लाई कर सकता है. सो हाउ टू डील विद दिस केस व्हेन यू हैव अनबाउंडेड फिजिबल रीजन? When you have unbounded feasible region, what you can do in this case, you can add constraints, either one constraint कि आपका region bound हो जाए, or you can also add both the constraints कि आपका region जो है bound हो जाए, right? Either you can add one, this or this, or there can be need to add two constraints that your region should be bounded. So what I am saying, so if I consider over here one line, if you see, I I'm taking m as very large value. If I'm taking line x, this will be my obviously line x1 equal to m, right? And this I can extend. Now can you see, if I have added the constraint x1 equal less than equal to m is very large value, right? So you can see your region has become bounded and closed. अगर आपका रीजन बाउंडेड और क्लोज हो गया है, इसका मतलब अब आपके कॉर्नर पॉइंट्स हैं. कॉर्नर पॉइंट्स हैं तो मैं उनको, आई कैन फाइंड दैट कॉर्नर पॉइंट्स, दैट दिस इज माय ए पॉइंट, दिस आई कैन टेक एज माय बी पॉइंट, दिस आई कैन टेक एज A point. This we will go in this direction. This I can take my B point. Now B point is nothing but my M and the intersection of this line, that your x2 is 0. And this is my C point, which is nothing. This is my, suppose I am taking C point, which is the intersection we have already find the line 1 and 2, and this line I am taking the intersection of the line x1 equal to m. इसका मतलब x1 तो m ही है, but this line constraint is, this line is second constraint, first constraint. So I can find the intersection. अगर मैं y1 को यहाँ पे m put करूंगी तो मेरा क्या आ जाएगा, that I will get y1 as 29 plus m by 4 y2. So you can put over here y1, that is m, minus 4 y2 equal to minus 29. So y2 you will get, that will be 29 plus m by 4. So this you got the point. Once you got the point, what is the next task? Find the optimal value at z. So what is my z over here? 3y1 minus 2y2 plus 22. So I can put the value ZA, ZB, ZC and ZD, right? Now my A point is 77,0. We have already obtained the value, that this is my 253, and ZB, this is my m, 0. So this is my 3m, and this point, C point is this, the intersection point that we have already obtained the value 23.33, and D point, if I'll substitute, I'll get 5m plus 15 by 2. So we got the point 5m plus 15 by 2. Now the task comes for the objective function. If I am saying my objective function is maximization, so what we have to do? We have to find the value, the maximum value ZA, ZB, ZC and ZD. Now, if you are saying, because we have added m, x1 less m, and m is very large, if I'll take m as 1000, so what will be my maximum value, which will depend, that will be by 253, this is 3000, this is 5015, divide by 2. So maximum value will be your 3m, right? Which is depending on m, which says D is the optimal point, right? But D जो आपका B, that means B is your optimal point, 3m. अब B आपका point क्या है, m, और आपकी optimal value भी किस पे depend कर रही है, m पे. If an m we have added for our feasibility, that the region can be bounded. If the objective function value depends on m, which you have added for your convenience, then LPP has unbounded solution. Why you are saying unbounded solution? क्योंकि आपने m जो लिया था वो अपनी कन्वीनियंट के लिए लिया था. आपने कहा m पॉइंट, अगर आप कह रहे हो m, 0 ऑप्टिमल है, तो m you have added as per your convenience. I can take m 1000, 10,000, crore, 1 crore, lakh. So if I'll take these values, my optimal solution will get changed with respect to m. So if your solution is getting changed, but that cannot be your optimal solution. Optimal solution is always fixed in this case. So like you have seen, this is the maximum case. यहाँ पे हमारे पास क्या आ गया? LPP has unbounded solution. Now the same case, if I consider it for minimization, I can choose ZA, ZB, ZC, and ZD. Now, whatever M value with the largest value I can take, you can notice over here, जो आपका M है ये 77 से पक्का बड़ा ही है. So these value you can always get minimum as the value as your 23.33. Now this value is not depending, which is corresponding to the point C, and C is point nothing but my 19/3 and 53/6, which clearly says y1 is 19/3 and y2 is 53/6. And obviously you can get the value as your x1, that will be your 25/3, and x2, that will be your y2 minus 8, that will be your 5/6. So this is the optimal solution in case of minimization. So you can notice here that कि अगर आपका मैक्सिमाइजेशन का केस था तब आपके पास अनबाउंडेड सोल्यूशन था, बट अगर आपके पास मिनिमम का केस आपने जैसे ही लिया, देन यू कैन टेक द ऑप्टिमल सोल्यूशन जो आ रहा था वो आपका बाउंडेड है, एंड द ऑप्टिमल वैल्यू इज नथिंग बट दैट विल बी योर 23.33, राइट? Either you can check here 3x1 star minus 2x2 star. So this will be my optimal value. So one thing you can notice over here, the one thing which you can notice over here, that LPP has unbounded solution implies that your feasible region is unbounded. But is the converse true? अगर तो आपका एलपीपी का सोल्यूशन ही अनबाउंडेड है, तब आपका फिजिबल रीजन पक्का ही बाउंडेड होएगा. दिस इज फॉर श्योर, राइट? इज द कन्वर्स ट्रू? नो, may or may not be. That you can verify from this example, that we have this case, we have feasible region unbounded, but we got the bounded solution, right? So this is not true. Okay, thank you.